Okay, so here are some notes to help out. They're basically my tutorial notes, I guess you could say. So objective of the notes is to get you guys to be able to simplify what are called complex fractions. So hopefully you guys know what a fraction is. So these are complex fractions. So basically when something is complex, it's kind of more complicated. So these are complicated fractions. So just in case you didn't like fractions, this will make you hate them. So here we go. Definition. So in order to do this, we should know what a complex fraction is. So a complex fraction is a fraction that contains a fraction in its numerator and or denominator. So it's a fraction inside of a fraction is basically what a complex fraction is. So for example, this. Here's your main fraction bar. Then you have your numerator, which is up top right here. Your numerator actually has fractions inside of it. That alone makes it a complex fraction. But sometimes not only do you have a fraction in your numerator, but you also will have one in your denominator. So that's pretty complex. I mean, most students kind of freak out when they see just 2/5. So now we decided to, yeah, make it even better. Simplest form. So that was a complex fraction. Now we're going to simplify these so that it doesn't look as messy as this. So technically everything that we're doing, we're still going to have the same value as this. So like if you plug this into the calculator and then we simplify it and then get another one, and then you plug that into the calculator, you're going to get the exact same value. Okay, so we're just simplifying, we're just changing what it looks like is all. So to get it in simplest form, you got to write it as a single fraction. So you shouldn't have fractions on top and fractions on bottom. You just have one fraction. Also, make sure that all the common factors of the numerator and denominator have been quote unquote canceled out. Basically, if you have the same factor in the numerator and denominator, it should be a 1, thereby saying that when you multiply something by 1, it's the same thing, so it's not really there. Now your final answer, kind of depending on your teacher, you can write it in factored form. If you write it in factored form, it shows that all the factors are different, because if you write it in factored form and something pairs up on the top and bottom, you should be able to cross them off basically. So standard form means that you just multiply everything on top and everything on bottom. So I'll show you what these look like though. I know a lot of people like to see what I mean when I'm talking about it. So let's go ahead and do this one. So let me copy this over here, and then we can actually just make a new page. So let's go ahead and do this one. So paste. So just with some numbers, because the ones coming up are much more complicated than this. I'm going to show you guys one method of doing this. There is more than one way of doing this, but this way I'm showing you is the way I usually show my classes. So right now, you guys have two things going on. You have a numerator, which is this, and you have a denominator, which is this. So you have fractions in the numerator and fractions in the denominator, which normally we don't like seeing it written like that. So I'm going to write the numerator in red. So it's going to be 4 over 3 plus 8 over 3. Now I'm going to write the fraction bar, I'll write in blue. This fraction bar right here, that means divide. So to kind of get a better grasp about what this means, I'm just going to write that division bar as a division sign. Okay, so now I have my numerator divided by my denominator, which I will write in green, so 2/5. Okay, so far all I've done was I rewrote the problem. Okay, so now what I want to do is I want to get this side as a single fraction. That way I'll have a fraction. Okay, so I want to get this entire side as a single fraction. That will have a fraction divided by a fraction. So luckily they have common denominators already. So 4/3 plus 8/3 is actually going to be 12/3. Do it in red. So 12/3. Let's switch all these colors. Divided by 2/5. Okay. Now 12/3 divided by 2/5. 12/3, I mean, luckily that actually turns into a 4. I kind of wanted that not to turn into a 4, but it does, so oh well. So we'll turn it into a 4. So 12 divided by 3, you can actually simplify that down to 4. Divided by 2/5. Okay, that is still not simplified though, because I got to put those two together still. For example, that would still say, if I were to translate this over here, that would still say 4 divided by 2/5, which I will still have a fraction inside of a fraction, which isn't good. So if you remember, the rules for dividing by a fraction is actually the same thing as multiplying by its reciprocal. So I can rewrite this again now as 4 times, so that division sign became a multiplication sign, and then I flip this fraction over to 5/2. Okay. Now it's just a matter of multiplying top times top and bottom times bottom. So 4 times 5, the bottom part here would be a 1. So 4 times 5, and I'll just make this in black now because all those colors are starting to give me a headache. 4 times 5 is a 20 over a 2. 20 divided by 2 is a 10. And that's it. Now, one thing is though, the way that you will want to do this, because you're not going to be able to do something as simple as 20 divided by 2 with the problems we're going to be doing. So we're going to be doing what's called factoring. We already know that the top is 4 times a 5 over a 2. That's for this 4 times 5, 4 times 5 times 2. Now, the method that we're going to be using is called factoring. So basically, we're going to prime factor the top. So 4 is a 2 times a 2, and then times a 5 over 2. And if you notice, this makes a 1 equivalent, so 2 times 5 is 10. That's the way that we're going to want to be doing this, because our fractions are not going to look nice and neat with all these integer, well, not integer fractions, but your numerators and denominators will include some variables, like this, see? So, yeah, this was just a kind of simple example. I guess you can consider that simple. I'll try to do this one with less colors and stuff, because that kind of confused me more than helped. So we got two things here. We got a numerator and a denominator. So we want to rewrite this with the numerator right here and the denominator right here. Okay. The fraction bar itself, we're going to turn into a division sign. So it's going to be 2 over x plus 2 divided by, and then you can keep this in parentheses too, just so you can see the numerators in there. So 1 over x plus 2 plus 2 over x. Now we got kind of like a little mini problem here. The mini problem is on this side right here. We got to get these things together because we want a fraction divided by a fraction. That way we can multiply by this side's reciprocal. So we got to get these two together. Now you should already know how to get add fractions. You need common denominators, so you need to change these denominators to the same thing. So the LCD between an x and an x plus 2 is basically you multiply these two things together. So x times x plus 2. So your LCD on this side is x times x plus 2. So now, let's put it divided by. We basically should do what I call in my class fancy ones. So I know that I want to make, hold on a second. I want to spread these out a little more. Okay, give me some room to work. I know that my LCD is x times x plus 2. So this x plus 2 right here needs an x. So I'm going to multiply this by an x, because now I'll have an x times x plus 2. But you're not allowed to just multiply a fraction on the bottom. Which you multiply by the bottom, you got to multiply on the top. That's, in my classes, I call that a fancy one, because x divided by x is a 1. On this side, I want to multiply by an x plus 2. But what I do to the bottom to a fraction, I have to do to the top, because I do not want to actually change the value. So you're multiplying by, like I said, fancy ones here. So this will be x over x times x plus 2 plus, because x times 1 is x, plus, let's go ahead and multiply this out, 2x plus a 4 over x times x plus 2. Okay, I'm just working on the right-hand side right now. So this is still divided. I haven't messed with this side yet. So now that they have common denominators, so we'll notice that the denominators are the same, you can go ahead and add the top. So x plus 2x plus 4 and then everything will be over this fraction. So x plus 2x is a 3x plus a 4. So 3x plus 4. Remember, all I did was I combined the x plus a 2x plus 4 is a 3x plus 4 over x times x plus 2, and then big parentheses. And let's go ahead and bring this guy down over here. So 2 over x plus 2. All right, so basically all we did was we rewrote the denominator so far. All right, these are lengthy problems. So now we have one fraction divided by one fraction. We can now multiply by the reciprocal of this one. So I'm going to go ahead and take the parentheses off since I don't have any more plus or minus signs. So that'll be 2 over x plus 2. This division sign will become a multiplication, and then I flip this one over. X times x plus 2 over 3x plus 4. Okay, now at this point you should basically make sure everything is factored out, because we only got a multiplication right here. So this is factored. This is x times a group of stuff. This doesn't factor. This does not factor, and the 2 does not factor. So what I normally tell my class is if it doesn't factor, put it in a group. So that doesn't factor, so I'm going to consider it one term. That's going to be one group also. So now when you multiply these, it's going to be 2. I'm just making this one big fraction. So top times top, 2 times x times that group of stuff, x plus 2. And then the bottom is going to be x plus 2 group times the 3x plus 4 group. Okay? Now, keep in mind, the only way that this bar, which means dividing, can cancel stuff is if the top and bottom are the same, kind of like how we did right here, where we factored it, and then we found out that the 2 top and bottom parts were the same down here, so the 2's canceled. So same thing here. Here we go. The only thing that matches is this entire group, the x plus 2. Circle it in red. This x plus 2 group and that x plus 2 group are gone. And that's it. You do not want to cancel, quote unquote, cancel this 2 and x with anything inside of a group. Groups cannot, you can't cancel just a piece of a group. Either the whole group cancels or you don't mess with the group at all. So the answer, final answer here, is 2x over 3x plus 4. All right, and that's it. That's basically how you do it. I'm going to go over another example. If you understand it by now, good job. I'm going to do one more just in case you need one more. If not, I mean, it's already 13 minutes, but let's try another one if you'd like. So with this one, we put parentheses in just to kind of get the idea of what the numerator and denominator are. Sometimes they'll put the parentheses already for you. I think in the pre-calc books they do, but in the Algebra 2 books they do not. So the top is in red, the bottom is in green. All right, so I'm just going to do it all in black, whatever. So 2 over x minus a 3. Hold on. I want to leave myself some room. Since I know I'm going to be working with this, I'm going to spread it out a little. I'm going to write it smaller and more spread out. So smaller and more spread out. So 2 over x minus a 3. So the reason why I'm leaving so much room is so I can leave myself some room to work inside of those parentheses. Divided by, leave some room, 1 minus 1 over x minus 1, and then leave some room. Okay, so just like on the other one, we got too much stuff going on. So this first parentheses is our numerator. We need to make it one fraction. It's not. This set of parentheses is my denominator. I need it to be one fraction and it's not. So it's like 2 mini problems. I'm going to do this one first. Let's go ahead and put these together. So you need an LCD. The new stuff I'm going to write in red. So I'm going to put this over 1. Now the LCD between the x and the 1 is an x. So I'm going to multiply this bottom part by an x, top part by an x also. So I'll do this side in red also. So this will be 2 over x minus 3 times x is a 3x over x. So as you can see, we got common denominators there. Gotta do the same thing on the other side. I'll do this one in blue. Now this 1 is a 1 over 1. Common denominator between 1 and x minus 1 is x minus 1 actually. So x minus 1, fancy 1, there you go. You now have the same LC. You now have the same denominator. So this will turn into x minus 1 over x minus 1 minus 1 over x minus 1. All right. So what we did here was we got common denominators. Like I said, this should have been taught in a previous lesson. Now I can put these two together, and then I can put these two together. So on the red side, 2 minus the 3x is 2 minus 3x. So you're going to get 2 minus 3x over x divided by x minus 1 minus another 1 over x minus 1. All right, so that was x minus 1 minus another 1 all over x minus 1. So let's go ahead and clean this up a little bit. Now, let's see here. So on the red side, you could leave it like that. Yeah, let's go ahead and leave it like that. Let's see what happens. So 2 minus the 3x divided by x. This is taking me a while. I gotta keep switching colors. X minus 1 is an x minus 2 over x minus 1. Okay, now we can factor these as much as we can. A lot of times you don't want your x over here, so you do want to rewrite this part right here. So this thing right here, I want to rewrite it a little bit different. I want the negative 3x first and then plus a 2. Just because that's normally the way it looks. So that's going to be a negative 3x plus 2 over x times x minus 1 over x minus 2. So I inverted it because I flipped that over. Okay. Next thing is to figure out what this is. Can it be factored? No. Can that be factored? No. That one can't. That one can't also. And if you remember from the other one, I said if it doesn't factor, put it in parentheses. So nothing. So when you do this one, it's going to be negative 3x plus a 2 times an x minus a 1 all over x times x minus 2. Now if you notice, that's time. It's a little bit off. Times and times. Nothing matches on top and bottom, so you're actually done. That's it. Okay? If anything matched up, then you would cross it off, and that would cancel out. So, yeah. But it doesn't, so that's done. Okay? So I hope this helped out, and if you have any questions about this, feel free to put it in the comments line, and I'll try to answer it whenever I can. Okay, bye-bye. I just realized something, too. Another, just because, here, let me explain this. Let me take that box off. No. Okay. So anyways, this could be considered your answer. Okay. But there's another way you could think about this. So I'm going to do this down here. So negative 3x plus 2 x minus 1 over x times x minus 2. This part right here, some teachers do like you to factor the negative out. So you could rewrite that as a negative 3x minus a 2. Okay? Because if you were to distribute this back in, it would be a negative 3x plus a 2. But a lot of times some teachers, not all, but some teachers want the negative outside of there. It's really all about teacher discretion at that point because technically these all mean the same thing. Um, so another acceptable answer is to bring the negative out to the front of the fraction. You have x times x minus a 2, 3x minus 2, x minus 1, and then that. But these two mean the same thing. So it just really depends on what your teacher wants as far as simplest form, but that's about it. Okay. Took a while to do two problems, but that's because I had so much explaining to do. All right. Okay. Bye-bye.